Okay, today I'm going to talk to you about distillation. We're going to look at simple distillation, we're going to see at fractional distillation, we're going to see the equipment required and how it works, and the difference between simple distillation and fractional distillation. Okay, so let's get started. Now, this here that we're looking at is an example of simple distillation. You can use simple distillation when you've got a mixture of two substances that have very different boiling points. So let's just imagine here we have salty water. So the reason why we can use simple distillation is because the difference in boiling point between water and salt, sodium chloride, is massive. Water has a boiling point of 100 degrees C, whereas sodium chloride has a boiling point of 1413 degrees C. So because there's a huge difference in boiling point, we can use simple distillation. So what we have here at the bottom is a Bunsen burner. Now this could also be a heating mantle. We just need to heat up this salty water until we get to the boiling point of water. So when this reaches 100 degrees C, we will have evaporation taking place. So remember, evaporation means turning from a liquid to a gas. Only the water evaporates at this stage. The salt does not evaporate because we need a huge amount of heat in order to evaporate the sodium chloride. So it's only the water that evaporates. Here we can see we have steam that starts to travel down this part here. Now, obviously the whole point is we want to be able to collect our liquid water at the end. We don't want steam, so we need to turn the steam back into liquid water. And to do that, we use this bit of equipment here, which is called a condenser. This thing here. Now the condenser needs to cool down the steam to turn it back from a gas into a liquid. Now, the way that works is we have cold water which flows in this part here called the condenser. Now, if you look really carefully, you'll see that there are kind of two tubes here. The water, the cold water which flows in there, flows around that inner tube. It flows around it, cooling down the steam. And as it does, we have condensation. That's why it's called a condenser, because the steam, as it's cooled down, turns back into liquid water. And there we have it right there. So we have clean water right here. The salt remains here because we do not get to that temperature, but the water is separated. It turns to steam. Then as it goes into the condenser, if I was to touch that, would be cold. We turn it back into liquid water. The reason why we constantly have the water flow in is to make sure the water stays cool at all times. If we just had the water sat there, it would get warmed up by the steam and wouldn't work as well. So that's simple distillation. The next thing we're going to look at is fractional distillation. Now the difference between the two is fractional distillation is used when we have a mixture of liquids with similar boiling points, or kind of much closer. So let's just imagine we have liquid A, which has a boiling point of, let's say, 60 degrees C. Let's imagine we have liquid B, which has a boiling point of 80 degrees C, and we have liquid C, which has a boiling point of 100 degrees C. 100 degrees C. Cool. So, at the beginning, we've got them all in here. So we've got a mixture of liquids here. Now, we can't use simple distillation because these boiling points are all far too close to each other. They'd come out at the same time if we use simple distillation, or rather similar times. It would be very difficult. So, instead we have this fractional distillation column. And towards the bottom of the column, it's hotter because we're closer to the heat. And towards the top of the column, it's colder. Now we could tell the temperature at the top of the column because of this thermometer, which is in the top. So what will happen is, stage by stage, each liquid will come out. Just the same as before, this is the condenser, and the condenser works in the same way by condensing the gas and turning it back into a liquid. So The first liquid that's going to evaporate is going to be liquid A. It's going to travel up the column and travel down here. When it gets to the condenser, that will turn it back into liquid water. If, let's say, liquid B evaporates, it might get up to around here on the column, and then it might just drip back down because it will condense here instead. So the first liquid you'd separate would be liquid A. So you can collect that whole liquid there first. What you could then do is, let's say when this thermometer then reaches 80, you could then go get another conical flask and collect your liquid B. So you move that conical flask out of the way because hopefully all of your liquid A would have evaporated, and now you could collect your liquid B. And finally, once you've done that, when this reaches 100, hopefully we should be evaporating liquid C. So you then move that conical flask out of the way and you can collect your liquid C. So quick recap, fractional distillation is used to separate when we have liquids with kind of similar boiling points, unlike in simple distillation, which we use when the two different substances have very different boiling points. Thank you very much.